Chapter 3, or Chapter 6, Section 3. We've been working with radicals lately, multiplying radicals, dividing radicals. Now we're going to learn how to add radicals. Just like if we were going to add variables. If I was going to say something like this, 4x squared plus 3x, can we add those two? No. We got x squared and we got an x. Okay? So we really can't add those two. If I had a square root of 3 plus a square root of 7, can I add those two? No. We're going to treat this just like it was x squared and x. We can't combine those two. Okay? But if we had a square root of 3 plus a square root of 3, then we can add those. This would be 2 square root of 3. Just like if we added an x plus an x, it would be 2x. All right? That's how we can add radicals. Now, what happens when we run into something where the radicals are really large and we can reduce them? Well, let's take a look here. And I'm going to use the example they have here. Square root of 63 plus the square root of 28. I know, it's small. Okay, I can break the 63 up into the square root of 9 times 7, right? Plus the square root of 4 times 7. Did you see what I did? Okay. Notice that I've got the square root of 7 in both of them. I've got a perfect square here, right? Perfect square here. If I pulled that 9 out, what's the square root of 9? 3. So I can go 3 square root of 7 plus square root of 4 is 2 square root of 7. Now I have the same square roots. And when I add them up, it becomes 5 square root of 7. All right. Stop right there? Think so? Pretty kind of easy once you see it, right? Here's the big part. Knowing what you have to factor these out at. You can. You want to find that in this case the 7s are what we notice. If we looked at 63 and 28, we should be able to see that they're both factors of 7. Or you can factor 7 into both of them. All right? Let's take a look at at one of the problems here. Let's take a look at number 6 is nothing more than the cube root of each one of these, right? If I take the cube root of something in 24, what do you think that would be? What 2 times 2 times 2 is 8, right? What am I left over with? 3. I'll bet you I can get a 3x in here and come up with a cube root of something. Divide 192 by 3. 64. 64, we can do a cube root of it. It's, what, is it 8? No. 4. 4, right? 4 times 4, no, that's 32. Well, you can figure that out. I've got you. I got you guys on the right path. All right. Let's take a look at this first one. Square root of 150 minus square root of 24. What do you think we could do in there? What do you think we could do in there to come up with a... What could we divide into both of these to come up with the same square root? I'm going to look at the smallest one first. Because I know 4 times 6 is 24, right? And 4 is a perfect square. So if I change this one here to 4 times 6, what would I divide into this one? 150. Not the 4. How about the 6? 6 goes into that 25 times. 25 times 6. See how I figured that out? Square root of 25 is? 5. 5 square root of 6 minus 2 square root of 6 equals 3 square root of 6. Not too difficult? Got it. These are just, they're same thing. What's that? Okay, got it? Let's take a look at the second page. Oh, yeah. Oh, yeah. Let's see, not that one. That one I want to take a look at. Oh, yeah. Oh, yeah. Huh? He does that? Does he do that? Well, you have to be able to multiply and divide these. You have to be able multiply and divide. Tomorrow, what do we won't even be here tomorrow. We got a lot to do here. Process the first one first.